Hi there, my name is Dennis Wrinkle, and I'm an engineer with the Metropolitan Utilities District, and I'm going to talk with you today about what we do to turn raw water into drinking water for the Omaha and surrounding area. What we do is we use a four-step process to treat the water. First step is sedimentation, second step clarification softening, the third step is disinfection, and the fourth step is filtration. And so I've got a couple samples here of some raw water, and we've already got step one taking place. If you can tell over here, there's a little bit of mud that's formed on the bottom of this jar. It's been sitting here for, I don't know, about 10 minutes, and that's the sediment that's formed, hence the name sedimentation. What happens is that when you get water, like from a river, like the Missouri River, you're adding a lot of energy. The water's falling, it continues to add energy. Water being a solvent, it will start to grab a hold. It'll start to grab a hold of some stuff, and it'll be able to carry stuff. The more energy it has, the more it can carry. And so what happens when I shake this up, you can see that it's more evenly distributed than as if we were to just have it setting down. When we took the energy out, the water had less energy to hold stuff, and so sedimentation started to happen. Also at that time, in the sedimentation area, we add a little bit of activated carbon. That activated carbon does a couple different things. One, it takes the fishy smell out of the water, and two, it also helps to neutralize some of the nitrates and the nitrites that naturally occur when the rainwater goes over like farmland. There's a certain amount of fertilizers and whatnot that will run off. And so the activated carbon helps to get rid of that. The next phase is clarification and softening. And what we do is we will add a little bit of permanganate. Permanganate will help take out some of the iron out of the water. Again, as water runs off, it grabs a hold of a lot of stuff. And it'll also help to make sure that there isn't any algae that are formed. Also in this step, what we'll add is we'll add a little bit of lime and a little bit of alum. And what happens is it creates what is called, in the clarification and softening stage, it will do what we call flocculation. And what will happen is the lime and the alum will grab a hold, the lime being a mineral, and will grab a hold of other minerals in the water and create what is called a flock. And you can kind of see it looks like little pebbles forming in there. The alum will grab a hold of some of the metals that are in the water, like some magnesium and some of the iron as well. And what will happen is it'll start to just fall right out of the water because that flock becomes too heavy for the water to support its weight. And so again, this happened in a matter of seconds. This has taken now up to about 15 minutes to happen. You can kind of see what happens. Lime and alum are naturally occurring minerals and metals, and so we use these naturally occurring materials to help us get more of the minerals and metals out of the water. The third step in the process is called disinfection. And what we'll do is we'll add a little bit of chlorine, a little bit of ammonia to the water. Those two things added together help us to use a total combined less chemicals. The reason why is because the ammonia helps the chlorine stay in the water longer. And the longer the chlorine can stay in the water, the more contact time it has, and the more things like protozoa and other things will get killed by the chlorine. Right here before the last step, we do also add a little bit of fluoride. We are regulated to 0.75 parts per million of fluoride, and it helps keep your teeth nice and healthy. It's worth noting that the Missouri River does have some natural fluoride in the water all the time. So we have chemists on hand all the time to make sure that we're not adding too much. The last step in the process is called filtration. What we do is, this is kind of a tube of the filter bed, and it is filled with a mixture of anthracite and sand. And what we do is we add a little, we only go with the top 1 inch for any of the filter beds. And then as the water goes through, the dirt and whatever is left over will get trapped in with the sand and the anthracite, and what we end up with is clean, clear drinking water. So this is how we treat our water here at MED. I hope you enjoyed the presentation. Thank you very much for your time.